Jeremy. I'm one of the partners here at Scale, 7 partners here at Scale. We got a good group of the team here and super excited to see you all tonight. For those of you who haven't been at one of these dinners or one of these events before, we call this the New Ideas in AI speaker series. We try to do this quarterly, and the big idea is to bring academic speakers and thinkers and have those folks share their ideas and mingle with the broader tech, entrepreneurial, and startup community. So this is our 4th event in the series. So we've gotten some positive feedback in past events. We had Jun Sung Park last year of the generative agents paper. That was one of the first academic treatments of what agents can do. We had Jason Wei of OpenAI, who talked a little bit about chain of thought prompting. So we're excited to continue the series tonight. And those of you who don't know Scale, we're a $900 million fund focused on Series A through Series C investments, very AI heavy, very enterprise software heavy. In the pre-LLM era, back in 2016 or 2017, we decided to make AI the focus of the fund. So invested in companies like Forter, Socure and Fraud, Locus Robotics and Robotics, Computer Vision with Viz AI and Spot. And in the post-LLM era, we've done a lot from Reggie AI, agents in the sales space, Tavis synthetic avatars. And in the last 3 or 4 months, we've added 6 or 7 unannounced deals, which we have on the sheet in front of you, from AI scribes to QA automation to AI calendaring. So we have been super busy. Voice bots, accounting automation. We've had one of our busiest stretches since 2021. So we are certainly open for business and open for deals. So that being said, let's turn to tonight's topic, which is direct preference optimization. I'm super excited about tonight's event. I saw this paper come out after the NeurIPS conference. I saw Andrew Ng say some really nice things about these guys over the Christmas break, and I decided then and there I just had to have these 2 speakers. So like any good VC, sent a lot of cold emails until we could finally make this happen. So excited to have these guys here tonight. The reason why I think this is so important is because direct preference optimization is not just a theoretical construct. It's already in production with Mistral. It's already in production with the Llama models. This is a real thing. We've got 2 speakers tonight. We've got Raphael next to me, who is a second-year PhD student at Stanford, came from the quantitative trading background in Goldman before that, so brings a little bit of finance a long time ago. And then we've got Archit, who's a 4th-year PhD, kind of finishing up the academic world and is now thinking about industry. So welcome these 2 and excited to have you. So thank you.
And thank you very much for having us.
Thanks for having us, yeah.
So the way we've tended to structure these is I'll start with a couple of questions, maybe 15 minutes or so, then we'll open it up to the audience for questions. So the aim is to have these guys speak for 20 to 30 minutes, and then we'll start the dinner. Maybe we start with Raphael. Maybe just talk a little bit about the overview of the technique and contrast it to the world that came beforehand, particularly proximal policy optimization.
Yeah, so maybe taking a step back, I'm really big, sort of like really aligns with my view, this sort of position that Jan LeCun has had on the cake. I don't know if you guys have seen the cake, but the cake analogy is like, in this sort of generative, general intelligent things, they're kind of like a cake where most of the filling, like the batter of the cake, is sort of some unsupervised, self-supervised pre-training, which is in language model world, this is sort of, large-scale internet data pre-training. Sort of the frosting is kind of like imitation learning or supervised fine-tuning, which is kind of like the SFT stage we have in LLMs. And the cherry on top is kind of like a small RL type of post-training and fine-tuning. And basically like 90% of the capabilities that you can get in a lot of generative AI systems come from the first 2 stages. And the RL part gets you the last 5%. But I think if you actually want to have a product, this last 5% are really, really important. And I think this last 5%, is why GPT-3 wasn't a product, but ChatGPT and GPT-4 are a product. But it actually, like this also last 5%, the problem is this is actually the most difficult part and potentially like the most, like least well understood yet. And OpenAI at the time developed, and that work builds on a lot of things before that, but they developed a way to do those slice 5%. They developed a way to do that cherry, and they were successful. However, that without getting into technical detail, that approach was very complex. It involved like a lot of steps. We actually, when you present this in slides, we have this one picture that sort of represents proximal policy optimization. It's one picture that has something like 40 boxes on it. And it's not only complex, but also like computationally expensive. So if you wanted to do it at scale, it's like very difficult. And they were successful because they had a lot of time and effort, spent a lot of time and effort to do this. And it took them actually a couple of years to really perfect that pipeline. And that gave us the strong models we had at the time. But essentially, it was really difficult for everybody else to reproduce that. That's kind of like where we started, kind of from first principles on that thing, because we actually had trouble with that algorithm to try to get it to train correctly. And we kind of started from the first principles, like first mathematical principles, and without going into technical details, like mathematically we saw like these like two things are equivalent, and one thing was actually like very much simpler to do than the other thing, and just the math like really beautifully worked out, and we went from something that has like on this one picture has like 40 boxes to something that has like 2 boxes. And something has like 100 hyperparameters to tune, something has like 1 hyperparameter to tune. And it's like insane, but like literally the first time like, we implemented like, I think Archie and Eric just implemented it over one night, and like literally, well, the first run we did, like the hyperparameter was like, we flipped like the loss function. But it literally, the second run we did, it just worked. That was amazing because at this point I had spent like 3 months trying to get PPO to work. And this thing just kind of like worked like overnight with like the first run. And then we kind of
out of curiosity, when, because I know when the paper won its award, but when did this all happen?
Yeah, this is another thing is like the whole paper was done over like 3 weeks before the NeurIPS deadline.
So roughly like May 2023? Yeah.
So, I mean, when we think about the actual implications of this, because I think you highlighted it well, which was OpenAI was working on RLHF for years. Like, you guys come out with this technique. There was one of the data science journals I thought did a good job of summarizing the conclusions here. It was 1, DPO means you no longer need an entirely separate reward model, so a whole lot less computationally costly. Compared to the prior technique, every time you update the data, your function actually updates. And then third, by providing the positive and negative training data, you can actually train the model to avoid certain topics, all without that RLHF kind of computational cost and time cost. My question to you, Archit, is, first off, did you agree with that summary? I think that was towards data science when they described the 3 big conclusions. And of those 3, which matters the most and why to the folks in the audience today?
I would say that summary is pretty decent, but I want to slightly take a step back as well. And I want to build on one of the points Rafael made earlier, is that when you're really building out the product for users, it's sort of silly to not involve the user in the process. So RLHF, the why it became so successful was because we involved the users who are going to use the product. They're going to tell us exactly what they like and what they dislike. And you get that feedback data, and you use that data very effectively to build these models out. And that's really the root of all the success for RLHF broadly and DPO as well. So in those points, and this whole technique is called we're learning from preferences. I think the third point is actually really critical because it allows you to control how your product is going to behave when you interact with the users. You're able to decide, oh, this is what the behavior we want, this is what we want it to do, and these are the things we want it to avoid. And I think that's a very critical thing. When you're building a product, you want to have good control over how it's going to behave. Especially with these language models, they can just kind of say anything at this point. They're trained on the entire internet. And internet says a lot of things. I don't want to hear all about eating rocks or something.
Putting glue on pizza?
Yeah. So you want to avoid certain behaviors, and this technique allows you to control these massive beasts at this point. So yeah, I think the third point is really important.
Rafael, to the extent that you're familiar with it and comfortable talking about it, I mean, obviously I know Llama is using direct preference optimization in production. We know Mistral is using DPO in production, and when Mistral came up with the first model, a lot of people were kind of blown away that DPO allowed Mistral to move faster and with fewer hyperparameters. So talk a little bit about what you know those teams are doing, and then talk a little bit around where DPO works adjacent to other techniques and where it replaces other techniques.
It's a good question. I can't per se talk about what they're doing because they don't necessarily tell me what they're doing. They've come out, they're using these techniques. Interesting enough, actually, publicly at least, the Llama 3 paper said that they're using both techniques, both classical PPO and DPO, but at this point they haven't really shared more information than that. Without revealing too much, I'll actually say I do know that like a lot of other companies are also using this sort of approach, so they're kind of moving to either not fully the core DPO formulation, but more of a hybrid approach. So more of like user in the loop type of things, or like merging like offline DPO type of things with online methods. At this point, I think all of the generative AI companies are experimenting with some of these things. To what degree they're making it into the production of actual like deployment models, I think actually depends on a lot of things. So like actually I know there are also companies that have different production models for different applications, and they actually use different fine-tuning approaches and things like that. So
I'll maybe add to this, again, without like revealing too much. So, I mean, first I want to give a shout out to like Hugging Face and AI2 folks, because they really like tried out a technique first, and they like put out some really strong models, which I think kind of like catapulted this technique to success. Mistral is a small team. Like they don't have like 5 people working just on RLHF. They could not afford the compute that it takes to get these models out. Whereas like DPO is like exactly their solution is like, it's an accessible technique. You can tune it on the compute you have. And you're really like going directly from the data to the model. Again, like as Rafael said, I'm not completely familiar with how different people are using this, but one thing you can reason about is that DPO is a good engineering solution. Engineering is all about building on stable performant things that you know will reliably work. And this is a good component you can add to your pipeline. So you can test that, did I collect the right form of data or not? And this is like fast to iterate on. If let's say your model is performing really poorly on some kind of data and you need to do a quick patch to your users, you probably want something that like works really fast. So this is where you can like put in DPO too.
And expanding the question, because most of the people in the audience tonight aren't building foundation models. They're probably working on top of foundation models. They're monitoring their infrastructure, their vertical applications. What would you say to founders in the audience tonight that are, vertical AI companies or infrastructure companies, how DPO impacts their business?
I mean, that's exactly when you need DPO. Yeah. If you're not building a foundation model and like you're using somebody else, how do you like fit it to your purpose? And DPO like sort of provides you like a very simple, accessible framework to like go from this like generic like reasoning machine that can like do arbitrary tasks and like kind of like coalesce it into like exactly what you want it to do. So I think like for any founder out there, like if you're looking to build your moat, like you need to like get the right data, get it to like the right application, and DPO will probably allow you to like, build that application out in a way that's actually effective. I think like it's a great tool for you founders and entrepreneurs to know.
And just one other quick note, it actually like also like really accessible. At this point, these algorithms have been like implemented and ported into like many like public open source libraries from Hugging Face, from NVIDIA thing, from Intel. And this is something that you literally like git clone some repo, like put in your data loader and just run it, and it will probably work for you.
And one of the practical implications, I thought my teammate Javier had a good question, which was you guys require certain pairwise data for your algorithm to work. And again, in the context of founders fine-tuning their own model, recognizing that the algorithm's available, how are they supposed to get that pairwise data, and how do you do that in the real world?
Yeah, so that's a great question. I think in of itself, there's many ways to get that data. Like the classical way it's been done, you actually like ask people to rate possible outputs. But I think like there's a lot of natural ways to get that pairwise data from interactions with users through things like, for example, corrections and things like that. So you can get a suggestion from your model, but if you're like, use that as a draft and you edit it and adapt it to your application, and that's like a very strong form of feedback. That being said, I'm also like pretty bullish on other natural forms of feedback. After the DPO developments, there's been other algorithms that use more natural forms of feedback, things like thumbs up, thumbs down, which turns out to be like a surprisingly difficult problem. And it's not as widely adopted yet, but we have been working on algorithms for sort of like binary type of feedback, which is a lot more natural to collect, I think. And actually just released this paper like last week with DeepMind. And I think there's going to be more coming in on that front as well, which kind of builds on some of the ideas from DPO as well.
Interesting. I mean, we haven't pre-planned this. I don't know the paper. What is the new paper, and how does it draft off of this?
They chose some very complicated technical name. Remember something like offline reinforcement learning for binary model alignment or something like that. How it builds off it essentially starts with some of the fundamental ideas from DPO, but because the formatting of the feedback is different, it actually requires you to build like additional sort of components to the algorithm. It works so far pretty good in the publicly trained model and data sets that released, and that's all I'm going to say. Okay. But I think there's like a lot more to build in that direction, so utilizing much more natural form of feedback that like are a lot easier to collect.
Archit, I know one topic that you've been passionate about talking about and thinking about is the idea of data saturation, both in pre-training data and data saturation when it comes to post-training, and this world of, as we've kind of gotten to the place where we are running out of data, we're trying to generate data. How do you think that trend plays out moving forward, and how does that relate to this type of work?
I think, look, that's a hard question. Yeah. People are spending billions of dollars on that. So I'm not going to solve that problem right here. I will say like there's data still coming here. Like, I mean, there's still more new data is being put online every minute. We still don't know how to use video data effectively. We are still working on the audio stuff as well. So there's always more data coming in. Yeah. So one thing that people are leveraging and already working on is like leveraging different modalities. But really, like we've only started scratching the surface on post-training. Like these machines are like, they know a lot. And you can, generate synthetic data from this and use to improve the reasoning of these models. So the question that comes to is like, I think the key question is like, how do we verify what is being generated? Is it correct or wrong? So what kind of feedback do we use? How do we tightly integrate it into like user loops as well? Yep. And I think like once we start unlocking those parts, I think we can come up with these like really drastic improvements in models, which even if we just stop pre-training today, I think like we can keep like improving the models for a long time.
Interesting. And the last question for me, and then I want to open it up to the group, is, the big question in the venture ecosystem is the capital outlays required to support these foundation models are really dramatic. And there's a lot of questions about foundation model convergence, both among closed source models. There's questions of convergence with closed source and open source. You guys are introducing techniques that reduce the OpenAI's claim to fame was RLHF. So in a world of newer techniques, what does this portend about foundation models, and what should the investor lens be on that?
I think that's a great question. So foundation models, they're probably going to be very commonplace in the sense that they're all, like, there's this increasing trend. We want to put more and more money into this and build a better foundation model. But let's take a step back and like, these foundation models are pretty darn good already. And like, we haven't still figured out how to build products out of them. So like, first step, maybe like we should like take a step back and like, how do we like actually commodify these things? Is probably like a good thing to ask. And I think that's where like post-training actually is incredibly important, even with the current models. So I would look into like which companies are going to like build the right product, how they're going to like put it with the right users, and like, do they have like the way to collect feedback loops and like actually improve the models or not? So yeah.
Interesting.
I have maybe a little bit more different take. I think, we talk a lot about post-training and all these things, RHI, because I think these were like new things and kind of harder things. But I think to really get like really strong state-of-the-art models, it's not one secret ingredient. It's like great knowledge, great know-how, great engineering, great systems every step of the way. I even think the way Mistral did it when they released their base models themselves were much stronger than other base models, even before any like ROHF or post-training. So I think this family of algorithms, like the DPO family, which has now emerged over the last year, potentially make post-training easier, better, more accessible, but don't necessarily give you the keys to state-of-the-art foundation models. So there's a lot of actual implementation things, and right now another thing I'm working through the process